Our next presenter is Zahscha Gonzalez-Medley of JHU APL. She's going to be presenting to us on XTCE and Unified Telemetry Definition for all missions. Zahscha.
Thank you for the introduction. And I want to thank you for the opportunity to present my team's research on this topic. Next slide, please. I wanted to highlight what we're going to talk about during this presentation. First, we want to state what the problem is that we encounter and why we wanted to investigate this. Next portion is going to be what XTCE is, what the benefits are, and just a little bit of how the XTCE, the overview elements of XTCE are being built. Then we will spend some time talking about the overall architecture and our approach to solve some of the cases that we've found. And also I will present a case study on some of the elements that we've been able to translate and some of the ones that have been a little bit more difficult for us thus far. And then we will talk about some lessons that we've learned during this investigation. Next slide. So currently our existing telemetry in Telecommand is encoded in an Excel style legacy proprietary format. There is at the time no unified model for telemetry and Telecommand data, which is a little bit difficult for us to share information in context with not only our internal teams, but also outside institutions that we work with, payload providers, and other agencies. And the maintenance of this information is also costly, and most of the investigation troubleshooting it's done manually at the time. Next slide. So what is XTCE? So XTCE stands for the XML Telemetric and Command Exchange. It is a description schema for telemetry and telecommand. It is a non-proprietary standard that was developed by the OMG organization in collaboration with space agencies around the world. It was born out of the need for a standard method to exchange telemetry information and telecommand information among agencies and also internally. It was adopted by the CCSDS as a industry standard. It supports communication between dissimilar subsystems, which it facilitates the exchange of this data and these databases, like I said, internally and externally. And many COTS and GOTS GDS systems support import and export of XTCE. So the question that we have is, during this investigation at the beginning was, can we take our existing model and translate it to XTCE? Next slide. And which we'll talk a little bit about in a few slides over. So I'm just going to highlight some of the benefits here. Early on, what we found was that the schema has type mapping to several programming languages, including C, C++, Java, Python. The standard encourages the use of inheritance to structure the definitions. It can enhance interoperability between existing and new FSW and GSW tools. It can improve workflow automation because you don't have to programmatically make rules and validation. It is all built into the standard, which gives us more opportunities to enhance multi-mission tools. The XTCE documents can be created and inspected manually via text editor or programmatically. And like I said, validation is built into the objects. There is extensive documentation. The CCSDS is the one that keeps not only the current standard, but also like a very, very thorough element description. We also get the opportunity to tailor the schema. So from the big subset of rules that XTCE provides us, we could take a smaller subsection of those rules and say, this is what we're going to use to define our telemetry, and it would still be valid XTCE. And it would allow us to define additional like metadata that our legacy format does not support, which would reduce maintainability and reduce efforts to adapt applications when changes to the schema occur, because all you would have to do is run a command to pull in any additional changes to the schema. Next slide. On this slide, I am just showing this is an overview of how the XTCE elements are put together. At the very top, you have a root space system, which is divided in two main sections, the telemetry metadata and the command metadata. A space system in this case is used as a term is used in place of spacecraft to be inclusive to other equipment used for space operations. So like GSE equipment, etc. An optional header can be defined, which includes documentation that's important to a mission, and it can be hierarchical as well. Next slide, please. And then this, since our investigation is focused on the telemetry definitions, I wanted to give you a little bit of a further introduction to what the telemetry metadata holds. So the information about telemetry included here is, so things are, you have parameters that are elements of a parameter type. You can reuse them throughout your definition, and the parameter types describe attributes of your telemetry, such as link encoding, alarms, calibrators, conditions, etc. Telemetry is then grouped together in these container blocks called sequence containers, and then which is a description about the packaging of that telemetry. Next slide. And now we come to what our overall architecture is. On the left, we see what we currently have. This is all code that is pre-existing and part of our operational system. In the middle is our current development effort during this investigation. And on the right, you have future development efforts that could result out of something like using XTCE for us. Next slide, please. So here, I'm just speaking about like just one element at a time. So the currently existing architecture, we started by leveraging existing code. We took the existing model. I mean, it was the way of us being able to easily try and convert what we currently have into objects that were usable for us. We have a CSV parser, which takes the legacy format and turns it into those to that Java model that we will be using. And then we made some minor refactoring to existing code to accommodate to some of the things that we needed to do in order to effectively make this translation possible. We also added a legacy format aggregator, which basically takes a group of CSV files and just puts them together in one object without losing track of references to other objects. We also added a legacy format comparator, which is being used currently to ensure that we are getting the resulting CSV file that it's ingested is also the output, which helps because we also added a CSV writer to aid with some of the bidirectional translation that we've been working to do. Next slide. Now, here's what we've spent the bulk of our work, and it's in this current development effort. So the current development effort includes the generated code from the XTCE schema. We just use JAXB, which is part of the Oracle Java library, and in that we are now using those to construct the elements from that, and then the XTCE translator, which is the translation, what we're going to be using to translate from the existing model to XTCE and possibly back to the existing model. And then the last part is an XTCE writer, which would take those Java elements, those Java objects, and basically marshal them into an XTCE database. Next slide, please. And then, so one of the things that we can do in the future, because we have the opportunity to use generated code based on the schema, is we can create more translators, and that's something that we would love to do in the future, is have more translators so that we have more opportunities to get the telemetry definitions in a format that is ingestible and in multiple ways. Next slide, please. So as a presentation of our case study, the first thing is our focus during this investigation has been telemetry. So commanding is not really, hasn't been in the scope. We have looked a little bit at it, but it's not nearly enough as we have for telemetry. We also wanted to understand, like, so how are the current concepts used? What is the usage that we have? And we built some scripts that were able to parse telemetry data from 2 different missions. And we were able to then realize, like, these are the elements that we should prioritize to translate, because there are some of these that are at lower usage and should be probably not necessarily need them because of the low usage that they had. And then the other thing has been the mapping of the concepts to XTCE elements. Most elements can be directly translated. So a lot of the lower level ones have been very easy to translate, like alarms. What was the other one? Calibrators and points have been quite easy to translate. However, we have some structures that have been sort of ambiguous, that we have some overly complicated ones that have been very difficult for us to interpret, and thus far we can't really conceptualize a good way of making it of translating it into XTCE. Next slide, please. So this right here is one of the outputs that we have for a easy, like, simple concept translation, which is a linear calibrator that gets turned into a spline calibrator. And the code on the right is actually the output of one of the tests we did using one of the objects, like one of the existing model objects, and basically putting it through the translator, and that's what the output is. And we were able to handle both the cases where there were conditions attached to them and the ones that didn't have any conditions. Next slide, please. Now we get into one of our more complex ones. This one is the unions, which for us in our concepts, we are using unions just as a C-style union that provides the capability of representing the same bits in two different ways. We knew from the beginning that this would be a difficult concept to solve in XTCE just because of how we were using it. And we sort of found a solution within XTCE, which uses an abstract container to sort of construct that union style data structure that we have on our current model. And when we thought we had a good grasp on this concept, we ended up finding an edge case that was unexpected. We have a nested aggregate that we just were not able to, because at the time we were not able to conceptualize. We've only found it once, which is interesting, and we're still working through it. But this one has been one of those head scratchers. Next slide, please. So here's the obstacles that we're facing at the time. It is not clear if we are going to be able to do bidirectional translation without losing important telemetry information. That has been brought up time after time, and the further we get into the investigation, the more clear it has become, but we're still not losing faith that that will be the case. Complex data structures are challenging to solve because just our current data model is not even anywhere near like fully translatable into XTCE. And the other thing is we may be able to translate some concepts to XTCE or most of our concepts, yet we can't guarantee that we can translate back to the legacy format. Next slide. So here's some lessons that we've learned so far. The business logic of the existing data model revealed that some of the concepts have rules that have hidden assumptions. An example of this was when a condition is referenced by an alarm, the business logic implies that the condition will only have one entry, which is bold because that's not how we thought it worked, and that's not how it was documented that it worked, but that is how the business logic is saying that it works. And then also it revealed that some of the definition order is important, but not always. So some of the higher level concepts like structures and packets, the order does matter. However, lower level concepts like alarms and conditions, those can be defined in whichever order. So that doesn't really matter at this point. Next slide. And just a quick summary. So there are many benefits of leveraging an industry standard. I feel like it helps us streamline certain things that will give us more time to do other meaningful work. So I'm always going to be striving to try and get the more people I can get, into adopting standards and doing things in a more uniform way. I feel like the more time we will have to actually do things that are more meaningful. Most of the concepts in our model are pretty straightforward to translate to XTCE. Some of them not so much, and we're working through those. We still haven't quite finished the investigation. And the key takeaway, if you take anything away from this presentation, is that a model structure made for a one-way translation may not be conducive to a two-way translation. And that's all I have for you today. Thank you so much. And if you have any questions, please let me know.
Thanks, Zahscha. We do have some questions in the Q&A.
Sure.
First one is from Rich Landau. Does the telemetry come down to the ground directly as XML? Question mark. Is the XML format not too bloated for bandwidth restricted data links?
So the first thing is that right now, so what we're working on right now, so the telemetry comes down in packets, and it is then interpreted by a COTS vendor, yes, using XML. The XTCE is just describing how that is going to be decommutated, basically. Yes, it defines description of how that will be, then decommutated. Yes.
Okay. Next question from Class Zemke. How do you plan to put the XML files under configuration control in the case that TMTC structures evolve over time? XML cannot be diffed or cannot be diffed for storing in Git, for example. We can have a TMTC definition tools. Oh, okay, Slack channel. Yep, absolutely.
Sure. Yeah. So this is definitely not going to be like the end. This is not going to be like the end definition, like as a the full like stored diff version. This is more for exchange. But so basically there'll probably be a different format. That's the one that gets CM versus XTCE.
But now, do you agree with that statement that the XML cannot be diffed?
I mean, because so the way that we are currently doing it, at least, we have, for example, once we go from XTCE to our data model, we have we built in some additional features in the code that will be able to compare those what's coming in versus what was inputted into XTCE.
Okay. Next question from Will Marchant. So how much work is it to take an ITOS mock configuration, for example, and translate it into Cosmos, for example, using XTCE? Is this weeks, months?
So we haven't gotten that far yet. That's the truth. We have been working hardest not only to understand our current model, but to facilitate that translation to just XTCE. I know that Cosmos and other COTS vendors do have their own interpreters, basically, for XTCE, and they do support a specific subset of XTCE.
All right, great. One last question from Lee Garbs. Our missions have had some difficulty managing the high-level split in XTCE between commands and telemetry. I understand the reason for the split, but we do have data constructs we use in both telemetry and commands. And it would be nice to define these constructs in XTCE once rather than twice, once for telemetry and once for commands.
Yeah, that's one of the constraints that you have is that sort of problem where you have to do some of the work twice, and yeah, so we haven't found a way of working around that yet. Like I said, we've been focusing on just the telemetry side, and we haven't even gotten into the commanding side yet, as of yet.
All right, great. We have several more questions, but I propose that we take this over to Slack. And so there was that recommendation to maybe making a dedicated Slack channel for that. So I'm going to recommend that Hunter and Zahscha just chat and come up with a name for that Slack channel.
Sure.
And then we can post all these overflow questions over there and continue the conversation. Thanks a lot, Zahscha. Excellent presentation.
Thank you so much.